Hi everyone. We're going to talk about workshop on aerostructures. Yeah, today's agenda would be like we're going to cover a little bit basics about aircraft structures, the structural elements in there, the forces on the aircraft structure, materials used in aircraft structure, and fasteners and their types. Yep. Basically, I mean, I think we all are aware of our automotives. We have seen them, we have drawn them. And just to emphasize about the structure as such in any of the equipments or automotives, the structure is the basic thing which actually takes houses and keeps all the systems intact for the better functionality. So the structure forms the basic skeleton of any equipment or an automotive or an aerospace. If you see any automotive, any vehicles as such, many of you might have already rode bikes. It has got a tubular section of a structure where a fuel tank is fit in, suspension systems are fit in, a digital meter is fit in, electronics, electricals, all these are fit into the structure. So the structure is the bearing skeleton of all the devices which integrate themselves to make the equipment or automotive or a aeroplane to function to the best performances. Similarly, aeroplane has got its own structure. So the structure is again loaded with many systems like pneumatics, electrical, electronics, surveillance, sensors, you name it, utilities, mechanical powers, fuel, and many other systems. So it's very important for us to actually know about the entire design of any equipment or an automotive or an aerospace or an aircraft. So let's know about the structure of an aircraft. Basically, the aircraft has got few major important parts, which is a nose. Nose is a tapered portion of the aircraft which comes at the front, just in front of the cabin of the crew, cabin of the driver, or I can say pilot, right? And this nose, the tip of the nose is considered as 0, 0, 0. I mean, the XYZ coordinates of the entire aeroplane is considered as 0 at the tip of the nose. So the nose portion has its own skin and structure to take the stress, to take the thrust of the plane when it is taking off, moving at its stabilized speeds in air, and as well landing, right? And fuselage of an aircraft is a capsule which continues with nose. This is the major portion where we actually have the passengers, luggage of the passengers and crew members and all the utilities left. Right? The wings, as you know, wings are the portion of the airplane which come out of the fuselage at an appropriate position as per the aircraft designs. Right? These wings actually help the airplane to fly, as you all know. Right? There are different different cross sections of this wings. Most of them might be knowing about knowing about the aerofoil sections. There are many aerofoil sections designed for this wing in different sections to achieve the required performance. The winglets are the ends of wings which actually are controlled surfaces, which are used in plane maneuver. Like the plane movement is being controlled by them. So these are controlled surfaces. The flaps are so similar. The flaps are, I think you can see the flaps. Flaps just behind the, they are just attached behind the wings, which are used to maneuver the plane in their altitudes. And there are horizontal stabilizers on the tail portion and vertical stabilizer. These two stabilizers help the plane to have its movement in a very equilibrium mode. In the sense, like the entire plane can take up surges in the atmosphere, and as well thunders in the atmosphere. So it stabilizes the flight of the plane, right? Even the horizontal and vertical stabilizers have got their own control surfaces, which also help the plane in maneuvering them, right? And vertical stabilizer has got a radar, which actually helps the plane to maneuver sidewards, right? Yep. So breaking down these structures into the built-up elements of the elements and the framework of the aircraft, we can see that aircraft fuselage has got four major members which contribute to the structure of the plane, right? The longerons are the members, which are the strong members, which run along the length of the plane, along the length of the fuselage. As I told you, it's a capsule. The shape of the capsule grazes around these longerons, which actually are the direct load-taking members, right? And the stringers are the cross braces, you can call it as braces, which strengthen by tying these longerons. Usually the longerons are four in number for smaller planes, and they might be more than that for bigger size planes, right? And these stringers are either welded or fastened to these longerons to keep them in position. And the entire structure is a very integrated framework for a fuselage. So at places where we need more strength, and at places where we have our systems like electrical systems, electronic systems to be housed, we use bulkheads. Bulkheads are the frames which are used intermittently in the fuselage to support the entire frame at certain design positions of the design sections of the fuselage, right? And this is again, I mean, these bulkheads are having stringers which support themselves. I mean, the stringers run along the length of the fuselage, which connect all these bulkheads and to form an integrated structure. So all these four important structural members integrate and form the fuselage structure of an aircraft. Okay, so when we come to the wing, we have got different kinds of members. I mean, we have got members like, structural members like ribs and stringers. Ribs are the basic, cross sections of the wing, which actually are placed at designed positions on the wing sections at different places, right? All these ribs are connected with stringers. These stringers are the intermittent members which actually strengthen all these ribs in position. And the position of each of these ribs are so important that there is a very huge tolerance maintained when they are positioned and as well assembled, right? There are spurs which actually, they are plate-like structures which are used at the places required. I mean, spurs are not used everywhere, but they are used at the later portion of the wing when compared to the stringers are usually everywhere of the wing, but spurs are placed at they are plates which are placed nearly very near to the flaps, right? And the skin which actually covers all over these structural members is fastened, I mean riveted. You can say it as riveted to these structural members so firmly that the skin doesn't deform while the plane is on airborne, right? And the wingtip is again a surface which actually covers the end of the wing, so that it can give a nice nice aerodynamic enclosure for the tip of the wing, right? The wing has, again, as I told you, wing has controlled structures. Yeah, as I told you in the previous slide, the wing flaps move back and forth. Even they have structures in between called as flap track beams, which actually guide the entire wing flap to go up and down as per the requirement of the pilot, right? And these ailerons are also they look a little like wing flaps, but they are a little sensitive than the wing flap. But they definitely function similar to the wing flap. Okay. When we go to the tail portion of the aircraft, we have got structural members like horizontal stabilizer, as I told you, vertical stabilizer, ribs. I mean, you can imagine that the entire aircraft has got structures running through it, so that the finished skin surface, what you see from outside, is so well done with the support of all these structural members. The horizontal stabilizer has also got ribs. It has also got stringers and also spurs. So depending upon the design requirement, they will size the ribs, spurs, and stringers accordingly. All these structures are integrated, right? The entire plane is supposed to be integrated. I mean, the safety of, you can say, like, there are your safety of all the passengers and the crew members there lies on the structure, right? And the tail portion has also got control surfaces like trim tabs, elevators, and rudder. Trim tabs and elevators are similarly like wing flaps and ailerons, but these movements should be they are for fine movements, and rudder is is used by the pilot to maneuver the plane sidewise, right? Okay, let's see the basic movements and the forces what you can find when a plane is in motion. When a plane takes off or lands, there is the entire structure of the plane is subjected to tension and compression, right? So there is a tension on top. Sorry, there is a compression on top where the plane tends to fold itself fold itself, its tail and the nose portion towards the center, and the lower portion of the plane is at a high tension. This actually happens because of its own weight. It also happens because of the design, because of the environment. We'll see it further what all the forces acting on, right? So when the plane stabilizes itself in the flight and it is airborne, it actually has to maintain these parameters. I mean, first thing is the lift should be equal to the weight. Okay, the lift is something what's important. I mean, lift is something which is actually simulated or given by the propellers, the energy given by the propellers by throwing the wind backwards, by giving the thrust for the aeroplane to fly, to take the entire weight through the air, is called as lift. Right? And it all the design aspects of the wings, the aerodynamics of the wings, the aerodynamics of the plane, tail area, nose, all this come into picture. But at a holistic view, the thrust of the propellers gives the force for the plane to take a lift, right? And the lift has to be more than weight if it has to be airborne, right? And the thrust, as I told you, the thrust moves the plane forward, right? I mean, you might have already, we all might have already faced it when we are riding on a bike at a very high speed. There is a huge amount of air, gushing on your face and going by your ears, right? So it's quite common. So this is the drag. This is the drag what you feel when you are riding a bike. The similar drag will be felt by the aeroplane, and we definitely call it as drag. Apart from all these forces, I mean, just imagine these many forces acting on the body of the plane. I mean, when it is acting on the plane, I mean to say that they are acting on the skin. In turn, they are acting on the longerons, on the fuselage, also on the structures, ribs, and stringers and spurs. All these members of the wings, the tail portions and vertical stabilizers or horizontal stabilizers. All these things are integrated. The skin is integrated with this structure, and the entire structure is taking the load. Maybe the skin is a direct area which is exposed to this kind of forces, but indirectly the entire structure takes its load. The rivets, the fasteners that are attached to join the surfaces, the control surfaces, the skin surfaces of entire plane to the structure. The structure is going through many forces. Apart from all this, when you are flying in a plane, you don't want to have the outer air which is outside the plane to gush into the capsule or a customer the passenger cabin. So the passenger cabin has got a different pressure, right? So there is one pressure, that atmospheric pressure inside your capsule, I mean fuselage, inside the aircraft fuselage, inside the passenger chamber, whereas there is entirely a different pressure outside the aeroplane or aircraft. So there is a huge pressure difference subjected on the entire capsule and aeroplane. So even that also induces a lot of forces where the design of the structure gets more critical to take up all these loads.